Okay. Maybe 1 second just to make sure. And then we will get started on our exciting topic for today. Let's see. Perfect. Okay. So hello and welcome. Thank you for coming. We're really excited. So today we're with our Certified Ethereum Professional Committee, and we're going to learn about what else? Ethereum. And this session's all about navigating Ethereum. I'm Jessica Levesque, C4's Executive Director, and I'm joined by our CEP Committee. And during today's session, we'll be explaining how Ethereum works using analogies as our baseline. But first, let's get started with intros. So, Cheyenne, why don't you get us started?
Hello, everyone. I'm Shayan Eskandari. I've been C4 chair for CEP chair for a few years now, and I'm happy to try to explain navigate Ethereum with a different analogy. So happy to be here.
Thank you, Cheyenne. We're excited to have you and everybody else. All right, who wants to go next? Dustin? I ask and then assign.
Hi, Dustin here from Singapore. Happy Chinese New Year to everyone who celebrates it, and happy to have this chat about using transport analogies for Ethereum.
Yeah, it's going to be a good one. Ken?
Hey guys, Kent Barton. I've also been on the CEP committee for a few years, longtime member of the overall Ethereum community. And I know firsthand how complex and confusing some of this stuff can get. So I'm excited to help you guys navigate Ethereum with some common sense analogies today.
Yeah, agreed. Sonal?
Hi, everyone. I'm Sonal, and I am one of the co-founders of Interweave, a consensus mesh spin-out around using ZK for enterprises. And topics like this are so helpful, and resources that we constantly link and resort back to in our conversations with enterprises because these are difficult topics to grasp. So I'm super excited. And over to you, Josh.
Hey, Josh McDougall, one of the founding members of the C4 organization and a proud member of this specific committee as well. I'm looking forward to using an aggressive amount of transport analogies to talk about Ethereum today.
Perfect. So everyone knows we spent a couple committee meetings going through and figuring out some examples, some analogies of how we can explain Ethereum using transportation analogies to try to bring this together in a way that will make sense. Fair warning, not every single analogy will work perfectly with the others, but it will definitely help you to understand more how Ethereum works and some of the different pieces and how they all come together. So one of the things we talked about and how this all kind of started is this idea of infrastructure inversion. And there's a video, a talk, and it's also a part of his book from Andreas Antonopoulos, who's one of our board members. And his talk is about Bitcoin, but it works with all disruptive technologies. And the idea is that anytime a new system is built, it's being built on old infrastructure. And it's always messy at first. So if we were to take cars, when cars are invented, they had to run on roads designed for horses. So unpaved, muddy, full of ruts, it was basically a mess. But that's because the roads weren't made for cars. So as the roads were developed and became paved, suddenly we didn't just have these, cars that are getting stuck in mud. We found out that the technology did work. It was just that it needed to have that bottom infrastructure. And I'm sure for all of us that are interested in Ethereum and love it, we have heard many people say, this won't work. This is never going to work. And that's also what they said about cars and electricity and a lot of other new disruptive technologies. So those of us that are already interested in Ethereum have heard this for a long time, but it's going to keep growing. And as the infrastructure surrounding Ethereum continues to develop, we'll see more and more how useful this technology is. And just like roads, when they're first developed, people are like, why do we need pavement? This doesn't make any sense. And suddenly we realize, oh, we can do scooters. We can do all these different types of tech. And that's what Ethereum is doing. It's continuing to build its own infrastructure. And traditional systems are already starting and will continue to run on Ethereum, flipping this paradigm just like cars did with roads. So we're talking about a disruptive technology, and we're acknowledging that sometimes with disruptive technologies, or rather most of the times, people say it won't work, but it is working and it's evolving, and we're going to explain how it's doing so with these analogies. So that was kind of a long intro, but I think it gets us in this mindset of how we're moving forward. And I think, Josh, you're going to start us out with some more specific examples of how we see this progression in other types of technologies like transportation.
There we go. Absolutely. So, also with early tech, there tends to be a lot of changes as we learn about what we should have, and what's going to make sense. Early traffic laws didn't really exist. No speed limits, no stop signs, no right-of-way rules. We didn't really know how to do things safely, and as cars started to be used a lot more, accidents started to grow exponentially as well. Crazy amounts of injuries and deaths, both because pedestrians and cars didn't really know how to coexist on roads. Do we know now? Hard to say. And also car tech themselves weren't being established or weren't being built with necessarily safety in mind. And as we went over the years, you also saw things try to get resolved, and standards try to be put in place, be it stop signs and speed limits and things. But those standards even changed over time. In this case, at one point they just decided, actually we're driving on the other side of the road as of this day, and that's something that everyone then had to suddenly change and figure out, okay, how do we now adapt to this new thing? So we're seeing over the years Ethereum kind of evolving to meet that, to meet these changes as well. And then this next example, we can kind of see the barriers that get put in place for technology. In this case, because cars were seen as causing such disruption to the roads and such chaos, harming pedestrians and also, most importantly, harming horses and scaring horses, which is causing a huge amount of issue. That laws were put in place that said every car could only travel 2 miles an hour, and you required actually a 3-person crew. You needed someone to stand out and basically monitor, one person to drive, and one person 60 yards ahead waving a red flag to warn people that this car was coming. If we assume that we still had such a rule today, it would be amusing to think of what a highway looked like with everyone keeping their 3-person team along with their car. Now, one interesting tidbit, though, is it was actually the locomotive industries that lobbied for this to take place, because they were worried that cars were going to remove a lot of the use from their locomotive industry. And arguably, they were very much right about that disruption. But it's interesting to see who is behind regulations that get put into place. And when we talk about the cryptocurrency industry, obviously there's been lots of fights about what regulations should be in place and should it be in place. And it's always interesting to see who is currently lobbying for certain regulations to be in place, who is putting in barriers to make a technology more difficult to use, more cumbersome to use, and then argue that it doesn't work because of those regulations in place. So it's always good to keep kind of a bit of an open mind when we hear different reasons for some of these safety mechanisms being put in place.
I think it's an interesting comparison to Ethereum and crypto in general, and that we're talking about the regulation, these companies that come in and they're actively trying to avoid having something like cars become popular, because like you said, trains would be their business would be impacted. And we see that with Ethereum and other types of cryptocurrencies where it actually negatively impacts other technologies because this is more advanced and might be more beneficial in some ways, but we've got the old systems pushing back so that there isn't this change that negates this former technology. We see it basically with tons of different technologies. So I think that this is really interesting. It's a good comparison. Did anyone have anything else you wanted to add relating to this infrastructure inversion idea with either the red flag men that walked around or cars in general related to Ethereum as a whole?
Yeah, actually, I want to add something before going to the next one, which is kind of like a gate segue between these two. Is like, so with the banks and like basically I don't know how to relate that to exactly this image, but with banks there is a lot of like times this idea of like pull transaction versus push transaction, which is a different infrastructure. Like before, if you want to like take money from someone's bank account, it's a pull transaction, meaning that you have to withdraw from that account, and you can't really deposit with just without anyone's knowledge, like anyone's permission. Like the bank needs to permit to you to be able to deposit, and they can withdraw. They can like charge back. But like with crypto, we've seen a lot of like these early on like tokens. You can just receive tokens from any address or NFTs from any address. There's a lot about like tax complications, but also like if you like spam tokens that you didn't want to. There was like a lot of attempts at trying to make tokens match the behavior, like ERC 777 or some way that like you need to approve receiving tokens, like the specific tokens. But we've seen that introduce so much complexity and also security issues that it's not really a best practice anymore to use such systems. Or things about decentralization and having some gateways or gatekeepers that can prevent transaction from happening. And these two words don't necessarily match in the way they work. So we've seen a lot of that, similar to the way the previous slide was like, things don't necessarily work the way we wanted to do. Decentralization is a different way. Like anyone can send transactions and you can't necessarily prevent them from sending you tokens, which before was
Yeah, I
not a
just have one.
problem. Like people wouldn't send you money and you're like, oh, I don't want money. Yeah, go ahead.
Yeah, I've got one thing to add to that as well. And one example of this is like, the implementation of the travel rule, which is that businesses have to share information about crypto transactions from one to the other, but that assumes that businesses are able to share and verify information about who sent the transaction, the beneficiary of the transaction. So it's an example of trying to form fit the legacy rules into a paradigm where businesses actually have a big challenge from trying to figure out from these pseudo-anonymous addresses how to implement the travel rule in that way.
Yeah, there's so many things that need to happen in order to make new technology work because we're changing all of these different pieces behind the scenes and we're actively learning, and there's always this pushback, and that I guess ties to the push and pull of transactions as well. Let's get into shortly, we're going to talk about some more specific analogies, but first let's just kind of transition in by talking about there's this evolution of infrastructure. So we talked about that with roads, but we're also seeing it with so many different things like self-driving cars. If anyone's ever been in a car that has parked itself, it's pretty cool to see how it is. This technology seems just wild. And, 50 years ago, it's like, yeah, that won't happen. Or it was, futuristic video, but we're here now where this is actually happening. And it's the same thing where you start with a car and then you move into this car that can park itself. And it's kind of like, whoa, but the self-parking car didn't start out of nothing. And we know that Ethereum had a lot of things that came before it until it got to this point that it's at now. And that is a crucial piece of information to know. It didn't just evolve out of nothing. It evolved based on all of these historical types of technology. And that's why we got to where we are today. And we're going to continue this example with cars as we explain it. If you have questions, you can put it in the chat. But let's talk about this evolution with both Ethereum and with cars. So let's get into the Ethereum blockchain and EVM. Sonal, do you want to get us started on how the Ethereum blockchain compares to the EVM and use an example with cars to get us started?
Yes. So now we can focus on one of the core components on how Ethereum and any of this idea actually work by comparing the EVM and blockchain. So we can think of the EVM or the Ethereum virtual machine as the engine of the car, where it's the powerhouse that converts fuel, in this case, smart contracts and code into actual outputs and functions that can be run. So just like the engine doesn't actually decide where the car goes, the EVM doesn't dictate the direction of what's going on top of it. It's the power of the actual blockchain for it to run smoothly, which in this case would be the body of the car. So the car itself has multiple other components that make it run, the wheels, the body, things like that. And it's the complete system that carries passengers, or in our case, transactions, to the destination based on the commands of how the engine is told to run. So they must work together. One without the other is nothing. You would just have an engine in the road or a body of a car that doesn't move. And what's really interesting as well about the EVM is that it's modular. So just like the engine that can power different car models, engines can be used across different types of cars. And the EVM can be used across different types of blockchains. And there are standards to how it runs. Is there anything anyone wants to add on that topic?
Yeah, I think that I mean it's neat that, you know, completely different cars might have the same engine under the hood. And with that, you know, there might be certain ways that you can interact with it or kind of understand, okay, I know it's a different car, but it's going to probably perform in this way that I can kind of rely on because of that. But even then, just because you've got, you know, the same engine in 4 different cars, if you put vastly different size wheels on those cars and different suspension on those cars, then those systems are going to perform very differently, despite being also very compatible in different ways as well. So the engine is, you know, a really core component of it, but that's also how all these different models of cars can really kind of diversify and have different kind of purposes and kind of niche areas in which they perform best, be it on roads, on the mountains, or in the air.
Yeah,
Um,
yeah, great point.
Yeah, I want to add something as like the other way around also. So like there's this conversation about EVM compatible versus EVM equivalent. So there's a lot of like we're going to talk about a bit later about rollups and other chains that they're EVM compatible. They have like similar engine, but in order for them to have this engine, the engine had to be slightly modified. So it's like almost the same. You can run a lot of similar things, but it's slightly modified. So there's like the both ways. Like the car needs to match the engine, and the engine sometimes needs to be modified to match the requirement that you need for that car to run. Some of them need to be waterproof. Some of them need like that kind of like analogy.
Yeah. And I mean, in your daily life dealing with Ethereum, you just might see these terms and it's kind of confusing. Why do I see Ethereum? And sometimes I see, oh, it's EVM. Just understand that Ethereum, the Ethereum blockchain, is a specific model of car that you're interacting with. It was kind of, you know, the first of its kind. But this engine that the Ethereum blockchain uses, called the EVM, is being used in all sorts of other projects as well, because it brings so much value to other projects, and being compatible with it is so valuable as well. So if you're wondering why, well, I thought I was dealing with Ethereum, but it's not called Ethereum for some reason, but it's saying it's EVM. Well, it's true. That's not the Ethereum blockchain. That's something related to it. It's something compatible with it, but it's going to be different than the actual Ethereum model of car that you're going to get into.
And a bit expanding on this, I just want to say like the similar to how much you might know driving, you might know your car perfectly, but you have no idea how the engine works. Similar to this, like you don't need to know how EVM works to use Ethereum. Similarly, if you know driving with your car, which is like a Mazda 3 car, you probably can start driving with the Cybertruck too, but you need some learning curves. There are some things different. You might try to find a clutch and doesn't exist. So like that kind of thing, you have to like make sure when you're switching between blockchain, the concept is the same. This you need a private key. You need it's kind of the same, but there's like these nuanced differences that you need to learn while using that blockchain, and how to use it safely also. So because some might have different requirements.
Yeah, and I
And I
think
also add,
oh, go ahead.
sorry, I was just going to add another thing to it, which is there's also this concept of composability, and you can think of it as having compatible parts of a car. So, for example, when we talk about things being composable, it means that it runs the same across different implementations, which could be that tires are a certain size, wipers are a certain kind of wiper. You don't have to get a custom thing every time. So, with standardization of parts, you have the concept of what we call in blockchain composability, where you have a part that you know performs a certain way as long as it matches a certain spec. So that could be something like a wiper, a roof rack, or something like that that follows the specific dimensions of the car.
I like that. That was really good. And along that line, we can think of your Ethereum wallet like a car's key fob. So it doesn't actually hold your ETH, just like the fob doesn't hold the car, but it does give you access and control to your account, just like a key fob gives you access and control of your car. So what is the Ethereum address? Well, it's kind of like your car's license plate in that it uniquely identifies your account so people know where to send Ether tokens. But unlike a real license plate, no one's sending, an actual package to it. You can think of it more like a digital address that people use to send value to your account. And here's the important piece in this is that the private key is like this secret code to get into your crypto, just like your car key is the access to your car. So you don't want anybody to be able to drive your car, I'm guessing, just like you wouldn't want anybody to get access to your ETH wallet. So you want to make sure that you protect it. You keep it in a safe place. You're not saying, hey, you see this $300,000 Maserati? I'm the owner and I'm carrying this key and I'm just going to put it in my pocket and wave it around. It's the same idea where if somebody's able to get the key, they're able to get access to the car. So we need to be careful with it. And then we could say that the public key or your address is like, yeah, the plate or the VIN number, something that it's okay for people to acknowledge and see, but it doesn't give them access to actually use the car or access what's inside it. Anything on that? Anyone wanted to add for an example before I keep going?
Yeah, I was actually VIN number was interesting because it made me think about how VIN number allows anyone to see the history of that car, also like get inquiry of that. That's a really interesting way of seeing it. For the plates, I was just thinking that you might not be able to drive the car, but with the plate number, you can find the car and I can send like tickets. So that's also another thing that anyone knowing your address can send you money or any token, and they can take anything away from you. But having the key, yes, they can drive the car away.
Mm-hmm.
I
Yeah.
was going to make a point about how innovation has kind of also been captured by this example. So, for example, keys for your car used to be very traditional. You used to have a physical key that you had to put in the car, and you had to copy the key was kind of complicated. And then we have key fobs, and then copying the key fob is kind of complicated. But now with the newer, EV cars, we've got things like you can use a Bluetooth dongle, you can provision a key that's a card, you can use your phone to unlock the car. So, as the industry kind of innovates, and cars are one of the legacy industries that have been one of the latest to innovate. As the car industry innovates, we're starting to see things that are similar to account abstraction, where the idea of one key and that's the only way to access it is also changing and evolving to make it more convenient, or giving people different ways of provisioning access to their car and their wallet similarly.
Yeah, that's a really interesting point. Now, if you have, let's say you've got a family and you've got 3 different, key fobs in your home, you can give one of those keys to your, teenage son or daughter who's just learning to drive and tie that car to speed limiters, or tie that fob to speed limiters in the car. So now you can have different keys that actually have different access to the same assets, with different kind of limitations or benefits to each.
Not
Change
allowed
that
to bring the
to,
car out after midnight.
yeah, change that to, years ago when it was just the physical key. If you had that exact same key copied to 3 different people in your family, you wouldn't necessarily know who was operating the car. The car doesn't know the difference between those keys. So it allows us to be a lot more specific, where in crypto world, in Ethereum, if you have an account with the same exact private key copied 3 times, you don't necessarily know who's creating those. But if you have account abstraction and 3 different keys given different permissions on those assets, then you can do kind of more fun things.
And we weren't going to get into any types of signatures, so I want to
We're
keep
not
this
we're
very
not good
broad,
at
but
not getting into things, so.
But I know it's impossible not to. Imagine your child, your teenager is going to start the car, but you also, in order for them to do it, you also need to say, give access. So like you could put all these parameters in, but also it could say you need 2 keys to start. So maybe you can do it digitally from your office, but once they put their key in, you also have to give them access to the account. So there's all these new types of ways to access the account and the way that keys are changing as technology evolves, but it really is similar to how cars work. I can't even imagine having had that be an option when I was a teenager. Probably would have been a good thing. But you can think of people not being able to have access, but they can. You just need to do that final step. Yeah, that's interesting.
And
My
made me
Ford
think
Focus
about
had a limiter, but it was different.
made me think about like how we have like parental control on the phones and the screen time limits that just like disrupts when the time reaches and like it stops, like let's stops,
Mhm.
makes me stop using it. I wonder, like, so similar technology is really nice for safety, like giving access to the kids, but like let's say if you use the same limits on that, you have like drive limits, and then in an hour it just stops. So that would not work necessarily for the car, because like if it's driving and just stops and they can just get stranded in the middle. Like there is like an interesting way of seeing how a safety or like parental control for one tech does not necessarily work the same for another tech. It needs the context. It needs like a lot other details of that. And also this is the first time I'm learning about the keys and the permissions of that, which is like pretty cool. Like I see technically that's possible, but I've never thought about that.
Mhm. Okay, should we go on to how gas works, fees, price,
Yeah,
limit? Uh,
I
so
can
you
just
got
start
access
that.
to your car with your key, but how are you going to actually do anything with it? What's the next step?
Yeah, so exactly that is like so there are the different ways of looking at the car. First of all, some of them are electric. Like we're not gonna talk about that right now because it's easier for gas here. And also, if you know, like some cars use more gas, sometimes use like less gas in like per 100 kilometers. So similar that is like we have gas, which every transaction you want to send requires some gas. A bit background on this, I just want to like more on the blockchain background because like we all talk about like blockchain is permissionless public network that anyone can use. And early on, especially on Bitcoin, there was this idea of like it should be even free, like so you should be able to send free transactions. But the main problem with that is like the one problem is you can't prevent spam. Like spam needs to have that like any transaction needs to have some fee so it prevents spam or makes spam expensive. And another one is for the network that is especially for Ethereum or things that have like virtual machines, smart contracts, you need to be able to pay the cost of like all these nodes running that transaction or running that process. So you need to pay that. That money goes to like the miners or validators at this point, and people that are verifying your transaction. So similar here, you need to fill your address with ETH, which is a gas here, and then every transaction you pay is like you spend that gas. You actually consume that gas so others can run your transaction. And the gas price is really, when you want to go get gas, you check the price and different stations have different prices, like really similar to that. Different blockchains or different layers have different prices of how much gas is used. If the demand is higher, the gas would be higher. And usually, like you may have seen that like um, on the same address, same network, same time, different transaction might use different amount of gas, and that's because the card that you guys are using at that point, or the smart contract that you're calling, requires more gas. It needs to run more kilometers in that sense, and that's where the gas limit comes in. That there's a limit on that, and you can't even fill in like I don't know how much, like a jet fuel amount of gas into your car. There's also that limit, which is like the gas limit on the blocks. So every 12-second, Ethereum has a new block, and there's a limit on how much gas you can spend on that. You can't really, at this point, you can't necessarily run an AI agent fully on chain, but you can run the inputs and outputs on chain. So there's a lot of that, but there's also the transaction outcomes that you still pay the gas when you send a transaction. The transaction can be successful and you pay the money for how much you spend, or the transaction can fail and you still pay the gas because you still sent that transaction. People and validators were running that transaction and the output is false, let's say. So that's why the transaction is failing or somehow it reverted. So it's similar to like you go to gas station to get gas, or let's say gas station to get, let's not use the gas station. You go to the store to buy something and the store closed. You still spend that gas and you still have to fill in the tank again. So those are really the analogy that can make sense with the car. But it also depends how different blockchains using the different, usually the native token or native coin is the thing you pay the gas with. Like in Bitcoin, you pay Bitcoin, BTC. In Ethereum, you pay Ethereum. There is this a bit harder maybe on the roll-ups and other layers because you still pay ETH, but that could be like more the general gas of the roll-ups, which we're gonna talk about soon. Um, if anyone wants to add something to the exciting gas conversation.
I guess one other thing to emphasize here would be the notion of imagine a world or a blockchain city where gas was essentially free in a way that sounds like a utopia, like, oh man, you don't have to pay for gas. But from a pragmatic perspective, with respect to like using these decentralized networks, there's a problem that arises if you don't have to pay for gas. If gas is basically free, you wind up with crazy congestion because anybody can access the network, and you expose yourself to say like what would be called like a denial of service attack, where anybody can anywhere can just endlessly enter this city or this blockchain with infinite vehicles, essentially, just as fast as they can put them in there, and then you wind up with a bloat. And this isn't just a theoretical thing. We've seen this time and again with blockchains that have attempted to have basically no gas or no fees. So it also ties into some of the stuff we'll talk about later in this talk about tokenomics and incentivizing behavior, because gas can also be used to incentivize staking, or validating on Ethereum, and it gets into even some fun layer 2 stuff. But yeah, it's not just a way to they're not, these fees are there for a reason. The gas is there for a reason, and it all is part of the big picture of making sure these networks can be permissionless, but also don't wind up collapsing under their own weight of users accessing them over and over.
Yeah, that permissionless piece is interesting too. Anybody can go to the gas station and get gas. I mean, if you're legal age and have a car, but so you need to have some setup, but anybody can go do that. They couldn't stop me from going and getting gas in my car. So I do need permission to do it, but then anybody can do it. Like, it's permissionless, but there's those little I'm not explaining this well. You have to set things up and then anybody can do it, meaning you have to have a smartphone or some type of access to Ethereum. But once you have those basic things, anyone can do it. Okay.
Just a bit of sidetrack here. I want to say early on in Bitcoin, when I was trying to write a Bitcoin wallet with Python, I sent a few transactions with zero fees. And it took like 3 or 4 months for those transactions to confirm. And I'm glad they confirmed, because I think today, if you send that, the nodes would just not broadcast a transaction. But it was funny, 4 months of it on confirmed transaction.
I think one more kind of interesting part on gas is similar to the gas stations go. There's not a like centralized entity in which you have to go and purchase this gas from that then allows you to participate on the network. There's all sorts of different gas station brands where you can go and get, it's the same, it's ultimately the same product. Gas is coming, like gasoline is coming out of that nozzle. But I can go to different stores and get that asset to then participate in the network, which I think is valuable. And also, as that gas is being spent, it's not going to the Ethereum business, one single entity. It's not a direct service fee to a centralized entity. It's how this permissionless decentralized network works. So it's a very valuable concept, but it's not exactly a service fee to interacting with it in the same way that you would either pay PayPal to make a transaction or purchase something on Amazon. It's a part of that whole tokenomics thing that Kent is going to get into later.
Yeah, why don't we talk a little bit about, we've talked about gas and you have to pay for gas and you do it in something called GUI, but let's talk a little bit about, I mean, we haven't discussed what tokens are or types of assets yet. Is there anything else we should say about, oh wait, sorry, I just jumped ahead. Nope, we got to talk about proof of work to proof of stake first. So never mind. All right, Kent, are you going to get into this?
Yeah, and this is cool because this analogy works really nicely with this topic. You guys may be familiar with the merge that happened relatively recently in Ethereum's history. First with sort of an initial piece that wasn't supporting the network, and then the actual transition. So what happened there at a high level is the consensus mechanism for Ethereum changed, and by that I mean the way by which this distributed network of computers supports and is incentivized to support the network by processing these blocks and adding new blocks to the blockchain. So this is a topic that we could easily go down a rabbit hole into its own thing. I think we did cover that in the past with C4 around the merge. But kind of one really important thing to understand is kind of this is one of the fundamental differences between Bitcoin and Ethereum, and what makes it so important is it relates directly to how to why people are incentivized to support the network. So proof of work is kind of akin to old school, I don't want to say old school, but the traditional way of powering cars. We go to the gas station and we fill her up, and this has been the case since time immemorial, since cars really were a thing, and it's very effective. So what's the analogy on the crypto side? Bitcoin started this all with proof of work, which is basically incentivizing people with Bitcoin rewards. And the way that works is they're processing blocks basically by solving really complex math equations with their computers. And computers can do this, but over time these equations problems become more difficult. Thus, it requires more computing power. Computing power requires electricity, so you need energy production, which there's always a cost. Anywhere on the planet, there's a cost associated with that. So what does it have to do with Ethereum? For the first several years of Ethereum's existence, it was also a proof of stake chain. So people were doing the exact same thing by spending money on energy, on electricity, to solve these difficult math problems, and then earn the right to add blocks to the blockchain, and then earn ETH for that. So even from its inception, the idea always was that instead of adhering to this kind of consensus mechanism, there was a vision that what if Ethereum could be more like an electric car? What I mean by that is instead of having to spend money on energy, users would actually just be staking or putting up their own capital at risk in order to do this. And then so basically kind of getting rewards proportional to how much they stake. So this gets like a little bit actually gets super nuanced here. But the big important difference to understand is no longer, and this has been the case since the merge happened. I can't recall the exact date, but it's been a while now, where the Ethereum network is now using, relative to what it was before the transition from proof of work, just a fraction. And by that I mean maybe a tenth of a percent. I mean, energy use, I think, dropped by like probably over 99% because it's such a big difference. You're no longer having to spend a lot of energy for computing power. This is huge. A renewable capital, Josh, thank you for that suggestion. That's a really good analogy in the sense that you know, with energy, you always need to be producing this. Staking, you just need to have Ethereum in the case of this network to stake, thus being able to perpetuate the consensus of the network. It's a very big difference. It also has societal and political implications because one of the primary criticisms, or I should say one of the many criticisms leveled at blockchain technology from a lot of political actors and observers was that you know, it's eating a lot of the world's energy, thus leading to you know, say pollution. Ethereum simply does not has basically taken itself out of the realm of that criticism because it transitioned over to this fabulous electric car we call proof of work, or I'm sorry, proof of stake. And a really cool sort of you know, follow-up to that is that it's worked fabulously. The consensus mechanism has been very effective. There haven't been any issues really with it. So again, this is a whole separate topic to really dig into. If you want to geek out, I think there's probably some archived stuff that C4 has talked about here, and then endless reading material. But despite the fact that we talk about gas in Ethereum, think of it more in terms of the you know, electric gas or something. It's green gas. We're not using any form of heavy amounts of really electricity like proof of work networks.
I think well, I mean, we debated even including this topic in this because it is a little bit nitty gritty. This is what's happening underneath the hood, if I can keep using car analogies aggressively. But one, it's a beautiful show of the evolution of this technology and how it is still like very significant changes are still taking place constantly. This is not something that's done. The car is not done. Blockchains are not done. These are things that are evolving a lot over time. And even as they evolve, Ethereum moving to proof of stake was incredible and did such a good like real environmental change to what was taking place as far as the consumption on that. But if we look back on cars, it's not to say, well, man, we sure did waste gas on every single car that ever existed. Well, no, those had real relevant uses, either to get someone to the store, to get products delivered around the world, to you know, manufacture the products that we use every day. It's hard to look back and say, well, that was wasted. It's not wasted. It has a purpose. But if we can improve things and change what we do going forward, that's also great. So
Just gonna add on.
Go for it.
Yeah, sorry, I was just gonna add on something as well because I am literally changing. Well, my ICE vehicle is, you know, coming to its end of life, and I'm actually looking at EV to replace it. And one other thing that I think actually fits the analogy as well is that I was talking about maintenance, and a lot of the people that were selling the EVs were saying, well, for maintenance for EVs, you basically have to change brake pads and replace fluids. There aren't these big complex parts anymore where, you know, I'll bring my vehicle in for servicing, like, oh, you've got to change your radiator, you've got to replace the air conditioning, you've got to replace this coil, you've got to do all of these things. Whereas with EV parts now, it's a much simpler machine, and most of the time it's fluids and brake pads. So it's not just about the consumption of gas, but it's also about the simplification of maintenance as well, and a lot less e-waste.
Yeah, like I have so initially when we were talking about like should we even talk about proof of work, I want to like add the section here because there are like some software updates in the world that I really feel that like we need to focus on and have more of that value that overall, like think about that when you're having like any software company, any big companies that like Ethereum from proof of work when they switch proof of stake. Inside, yeah, we can say 99.95% less energy, but outside, zooming out globally, it reduced the electricity consumption of the global electricity consumption by 0.2%. And that is beautiful. And I want to see more of that. And there are like some other updates, like if for some of the audience that have like Flipper Zero, these like hardware hacking, open software, they recently, like around a year ago, they had an update that increased the battery life from 2 days to 30 days by just like optimizing things, which was like, I haven't seen that in any other device. I didn't know if that's even feasible. And now, especially like the topic of the day, kind of like deep seek AI is like, instead of like throwing more money and more GPUs at the AI, just go down deep and try to optimize the memory use and like the use of the algorithm. So there's like a lot of things you can do with the software updates that kind of like seems impossible at first, but then you're like, we can optimize things. And software engineering has come a long way since like 50s, 60s when like pre-car designs. So that's one of the things I want to add. Like there's so much of that energy out there. And I want to see more of these kind of updates that have global impact.
Well, and this is the whole thing with technology. People kind of say, this doesn't make any sense because the infrastructure, like we started talking about at the beginning, has not been built. And then once the infrastructure has been built and it starts to grow and you can see how you can use it, it then evolves, progresses, and then we get to the point where we can do these small things that make a huge difference, that make it more functional, useful, cheaper, more efficient, scalable, all of these things. So it's like it is growing. And I like this analogy with cars in general because it does follow alongside. But I think if we were to pick any technology that was sort of poo-pooed at the beginning and then became something that everyone understands, accepts, uses, and finds value in, I mean, it's any example would carry through like that because that's what Ethereum's doing. It started with a few people who thought this is great, but there's issues with it. And then it's slowly become more and more people building and changing it so that it works for many, many people.
At the start, everyone just wants a faster horse.
Everybody just wants, oh, sorry, what was that?
A faster horse.
Oh, a faster horse.
Yeah.
I agree. I think that's the case. And then suddenly the horse is, has wheels and it's working well.
It's in a way, Ethereum was supposed to just be a carriage, an added trailer on the Bitcoin blockchain at first. It was supposed to be built into that, and then evolved into its own thing, which we see too. Different things that start off as related projects end up being their own independent but related system, which I think is pretty much what we'll talk about in part 2 of this, as we have half a presentation to go and we're running out of time.
Yeah, absolutely. We will do a follow-up where we get into the second half of our slides, which I always worry that we won't have enough content. And then every time we can barely get through it because there's so many different things that connect and the technology is so exciting. We all have so much to say about it. So we got through half of our slides, not even. And so in the next talk, we're going to go through different asset types, tokenomics. We'll talk about how mainnet versus testnet works. Going to look at different examples of scaling. So layer 2 solutions. We're going to talk about different types of roll-ups, side chains, bridging, all of that fun stuff. So the second half will be in some ways more technical, but it'll still be really accessible because we're going to keep this analogy going. Is there anything anyone wanted to add to this before we're done for today? Anything we missed or any topics that piqued your interest that you didn't get a chance to make any comments on?
I think there are a lot I want to say, but like just one thing that just came up to my mind I want to say is like a lot of this technology, like when Dustin said the faster horses, is like similar to the technology we've seen. Like early on when like Siri came out on iPhone, everyone was like, this is the future, like the smart assistants are the future. And now comparing the ChatGPT voice, like even the free version to Siri is just some like stupid if-based like software. Like we can't really compare. Like no one looks at Siri as like a smart the future at this point, which is interesting because it's not even 10 years that we've seen this technology that came. So a lot of things we're saying even today, in 5 years, we might look back, we're like, oh wow, that was so simple that we were trying to explain. And now it's like so complicated and so much better. So hopefully we'll do more of these streams in 5 years and debunk ourselves.
Well, and somebody put into the chat that in 5 years, all the panels will be AI. So it's kind of ties on. I don't think we're going to be going that way, but it could.
I already am. I already am.
I also wanted to add that I really liked the car analogy because Jess, you kind of mentioned it with the evolution and the infrastructure needing to be built, but obviously the topic of transportation and automobiles is so vast. You can't have a change overnight. Just like in the Ethereum space, we're not talking about just some new function or capability to an app you're using. We're talking about really rebuilding the way that something huge like transportation is done and a whole new system for it. And every nuance has checks and balances in place and different variables and qualities that have to be kind of balanced out, like scalability or time that it takes for something to happen or safety and things like that. So you're always comparing different factors as you're making those changes that impact real people and the systems as a whole. So it takes a lot to really build this technology in a way that's usable. So I think, when people are like, I've been hearing about Ethereum or blockchain for years and nothing really happens. And then something super exciting like AI starts coming out or is more prevalently spoken about because of the tangible uses of it. It makes it seem like blockchain is dead or that it actually is not viable. But what's truly happening is it's still really being built at its foundation to have the long-term purpose that it's supposed to have for the internet, the way computers are currently set up, and for people.
I
Yeah,
think
I
that
want to add
there's a
some.
bunch
Yeah,
of
go ahead, Dustin.
Now, I also think that there are a bunch of things that are being researched right now that are relevant to AI agents as well. We're talking about zero knowledge proofs that can be used to validate that computation was done correctly in some cases. There are also lots of use cases for privacy preservation techniques, and a combination of those. You're looking at AIs now that can run locally so that your information is not being leaked out to whichever server you're running it off. So I think that a combination of some of the research that is being done in the blockchain space now with regards to zero knowledge proofs and privacy preserving techniques, fully homomorphic encryption, those approaches are actually going to augment and enrich the AI space. And I don't think that it's one of those things where like our space is not innovating and all the innovation is in AI. There's a bunch of stuff that's being done in the blockchain space that will actually improve the AI experiences as well.
One thing I want to add, Sonal mentioned like the infrastructure that we need and also the safety. And I want to loop back to how Josh started this live stream also. So it's like even like my thing is more security and like even for security of these devices, like the image of like someone with a red flag walking in front of the car. So that was like what the regulation back then thought that's the way to use this safety and that's the way to do it securely. And even later we realized with the keys, like the physical keys required to like open it so anyone can just not take your car. And then now with the digital card, there is like this evolution of security that we know, security and regulation at the same time as like how to use the car safely. And later on, there are like these interviews if you Google about um, drinking and driving becoming illegal, and people are like really pissed. They're like, no, I want to have my drink and then go for the drive. So like there's a lot of those in the history of cars if you look at it, and we see that similarly, like similar to the infrastructure that this whole space needs. The security of it is just also evolving. It's so different than what we used to. Like a lot of these like people in research and the security communities, they know for the last 10 years that using username and passwords for like internet and securing your identity was wrong decision. But now it's the momentum has passed. We all know internet as the way to use username and passwords. But I believe there is a much better, safer way to go through this. And Yeah, so just want to add this as like there's so many layers of these like evolution that it takes time and you need to forget what you know from before and there's like new way of looking at how to safely use the technology.
Mhm.
Yeah, and on that point, I'll kind of give one of my closing thoughts for the stream as well, that there's so many components that you can learn about. And like we mentioned in the past, you don't quite need to know about how all of them work. If you're just starting to use the technology, you know just need to learn how to use your keys and drive the car. But if you want to start using other capabilities, like across different blockchains or what have you, you don't just get into a Tesla and turn it on to self-driving without reading the manual, learning the safety protocols, and things like that. So a lot of these topics that we're covering are to enable you to learn more with C4, as opposed to make you think that you have to know everything about every topic. It's just more so that there's a lot to learn about, and they are all their own topics themselves. And they piece together at these higher levels to kind of um, go back to the greater function of being able to operate. Um,
Mhm.
yeah.
Yeah, absolutely. Well, that takes us perfectly to the end of our time. So we will be back for the follow-up where we talk about additional car and infrastructure analogies that have to do with Ethereum and connect it all together. I am so grateful for you guys all to have joined today. We'll see you at the next one. And in the meantime, make sure to drive safe, transact safe, keep things safe, secure, but keep using Ethereum. So thank you guys for joining. Thank you to our CEP committee and see you guys next time.
All right.
Thank you. And don't transact while driving. So
Got it. All right. Thank you all.